We're going to do today, starting chapter 7. We're going to do 7.1, which is trig identities. And this is not going to be in the midterm. And it won't be in this week's homework due on Sunday, right? But I want to get this done because next week things are going to be quite hectic. Monday, as you know, is going to be your midterm. And then we have the rest of the week, and I want to get a head start on that. So you don't need to worry about the homework on this topic yet, or that you need to revise it for the midterm, right? It's not going to be in it. Tomorrow, we're going to spend our day revising for that midterm. In other words, we're just going to go over topics, questions, whatever you think you might be stuck at, and do some more examples, maybe help you get ready for it. So that's what tomorrow's going to be about. Let's get started on what are known as trig identities. Trig identities are expressions that you can rewrite in a different way, and they are identical to each other. So here are some trig ones that we are considering to be just known. In other words, you can memorize them and they are true because we tell you they are true. I think most people have seen sine squared plus cos squared equals 1 somewhere in their high school career, right? You remember that one? Probably the only one that most people do remember. But I'm going to add to that list. I'm going to give them numbers. That way I can say number 4 and you'll know which one to look at. And there is no particular order to these guys. There's one. There's a few to get started with, right? These are identities, trig identities. What that says is that this is exactly the same value as that. They are equivalent. They are identical identities. And what we're going to be doing is we're going to use trig identities to simplify trig expressions. So I'm using a lot right now with all my calc classes. I call it style points. And what that basically means is that when you're doing something algebraically and you've got an answer, you should try and make it as simple as possible, right? As nice looking as possible. I call that style points, right? So if you come to the party, you're not washed, your t-shirt's ripped and your hair's everywhere, you're getting a 1 point, right? And if you come up looking really good, you might get a 10, right? Style points, right? Really good looking expression, 10 points. A really ugly, messed up looking thing, not a lot of points. So that's just the analogy I give. I call it style points. Technically speaking, it is simplified, right? So you simplify your expression as best you can. There are 3 main rules that you use in simplifying. One is you should make your answer look like the original as best you could. The second one is you should factor the heck out of it. And lastly, you should use trig identities. And we're only going to focus on using trig identities to simplify your expressions. It's a difficult topic until you get practice at it. It's one of those things, the more practice, the better you get at it. Because you'll say, oh, I saw that before and this is how I made it better. So right off the bat, here is our first one. We're being asked to simplify 2 cosine t tan t. And they're really nice because they told us to turn everybody into sines and cosines and then simplify. And that's one of the tricks. If you've got an expression and you're being asked to simplify it, right, you would probably want to do that, you know, change things. So what do I have? I have 2 cosine t, and the tangent of t is number 2. Now, do you notice I'm using theta, but this is t? So would you agree that's just cosmetic, right? The letter doesn't matter, it's the same relationship. So this is going to be sine t over cosine t. And it's not uncommon for things to cancel. And the answer comes out as 2 sine t. So we have just simplified our first trig expression. Ugly, simplified, nice. Are we good with that one? That's probably the easiest you're ever going to see, right? So don't get too comfortable yet. This is question 3. Tan squared x, take away secant squared x. Well, isn't tan sine over cosine? Right. Number 2. Tan is sine over cosine. So tan squared is sine squared over cos squared. Are you happy about that? Does that make sense? What's a secant? Well, a secant is number 3. And a secant is 1 over cosine. So a secant squared is 1 over cos squared. I get a little distracted there because I thought I'd done it wrong, but I know I've done it right, so I'm okay. Now, when you want to simplify things, you have to combine them, you have to factor them, you have to cancel them, you have to do whatever you have. In this particular question, the only thing that looks obvious right now is, since both denominators are the same, is couldn't I just combine them? And you might be looking at that and think, that's it, I can't do any more. But that's not actually true. Do you see number 1? This guy up here? Okay. Number 1 can be written in lots of different ways. If I rearranged it, couldn't cos squared be called 1 take away sine squared? And couldn't sine squared be written down as 1 take away cos squared? And all I do there is subtract sine squared from both sides or subtract cos squared. Now, let's look at sine squared minus 1. I kind of like sine squared minus 1. Is sine squared, can I write that some other way? Can you write sine squared some other way?
Inverse? Or no, just kidding. Sorry.
This one, right? Couldn't sine squared x be written as 1 minus cos squared x? Let's see where that takes us. 1 take away cos squared x minus 1. So that's sine squared getting replaced by that. All over cos squared x. Oh, the 1's cancel. Negative cos squared x over cos squared x.
-1.
-1. Are you surprised that that ugly guy up there ends up being -1? Kind of surprising, isn't it? I think so. So I'm going to add to my list. Tan squared theta take away secant squared theta is -1. Secant squared theta take away tan squared theta. If this way around gets you -1, what do you think happens if you switch places? What number does it add up to now? This way around, you get -1. If you switch places, what number do you get now? Any suggestions?
+1?
Yeah, you can check it out. You could do secant squared take away tan squared and go through all this work and find out that it's 1. So I now have a couple more guys that I might use in the future. It's a bit like building a wall, right? You put the first row down and then you find stuff that makes the second row. And then you find some more stuff and you make the third row. Can't you kind of grow and grow with things that you can do? So if I ever get a question and I see a secant squared minus tan squared in it, won't I just call it 1? Right. So I'll make this one up. Suppose someone went and said to you, secant squared theta, take away tan squared theta over sine theta. Oh, I recognize that guy. I did him once. He ends up being 1. Would you agree that that's a much nicer looking answer?
Can't you technically simplify that to cosecant?
You nailed it. And we should. We should always try and simplify it so it doesn't have a fraction. If it's possible. It isn't always possible, but when it is, you should do it. So that weird, ugly expression, didn't it come out as something quite nice? Now, you can't keep adding to your list because you'd have hundreds. So you're kind of selective about the ones you're going to keep and the ones like this that you're just going to say, well, if I need to know it, I'll just do the working I just did there, and get it that way.
I thought secant was 1 over sine, not cosine. I don't know why.
Yeah, secant theta is 1 over cosine.
Yeah, for some reason I was thinking cosine.
Well, I think, I have the same problem. It starts with an S, doesn't it sound like it should be sine?
It should be sine, so 1 over
Right.
sine.
And the other one is even worse. That is 1 over the sine, isn't it? But doesn't it sound like it's cosecant? It's got a cos kind of name to it, isn't it? Very distracting. That I have no control over the names. I wish I had. I'd probably make up names that would help you get them the right way around. I'd probably call this 1 over cosine. I'd call an up cos or something, or a down cos, right? I'd make up my own name so it would make sense. But we're stuck with them, so we just have to remember them, I guess. Secants are cos. Actually, don't you just need to memorize one and then you're okay with the other? So if you know what secant is, you'll figure out what cosecant has to be because it's what's left. Now, this is quite different from anything else we've done, isn't this? This is really algebra, but a trig kind of algebra. It's not like factoring or combining x's together. It's a different kind of world, and it is difficult for people. So this is a version of question 4. I have a sine of u, and we have a cotangent of u, and we have a cosine of u. Okay. Anything you think we should do? What would be a good move just to get the ball rolling?
Could we turn the cotangent into cosine over sine?
Yes. So if you are looking at a trig identity and you think to yourself, it isn't one of these guys, right? I can't use one of these guys at least directly. A good backup plan is turn everybody into sines and cosines, right? Which you can certainly do, right? All of these help you do that, agreed? If I need to turn a tangent, I can find it. If I need to turn a cosecant into sines and cosines, I can do it. Now, what's going to happen next kind of depends on what you've got. And I don't really like what I've got. And this shows you, I guess what I'd call it, the complexity of this process. There are so many things that could happen, right? Each one's almost unique in its own way. Right now, we have to figure out how to make this work. And my brain is thinking, I want to get these two things together, because if I can at least get them together, something nice might happen. Because right now I've got two separate things. One's a fraction and one's not a fraction. And I don't have any real, idea of how this is going to become simpler. So I'm going to turn this guy into a fraction with sin u on it. And I'm going to do that by multiplying the top and bottom by a special version of 1. Right? As long as you do it, isn't that essentially 1? And what that allows me to do now is sin times sin is sin squared u all over sin u. So that's basically sin u being turned into this fraction. I'm not going to do anything to this guy because I don't see any need. Where do you think I should go next?
Can't you combine them?
Correct. Since they share a common denominator, I could combine them. So I've got them together, right? That's what I call getting them together. Do you recognize anything nice? Because I do.
Yeah, the top just equals 1.
And 1 over sin u is really nice. But what do we call 1 over sin u? What's 1 over sin u equivalent to?
The cosecant?
Yes. Finished. Do you see how sneaky that question was? That I love these questions. Maybe some of you hopefully do love them as well. One of the things I love about them is they're like puzzles. And each puzzle's a little bit different from the last puzzle, right? So it's not like doing a question, then you just do 10 more so you get good at the same question, right? Every one of these almost every one of these is a little bit different from the next one. And that's part of the fun. And it's definitely part of the challenge. Oops, I'll do that again. I misread the question. Whoa. Kind of different. I don't think we've seen one quite like this, but I'm going to start it the same way I did all the others. And that means don't I turn everybody into sines and cosines, right? If you can't think of what to do, turn everybody into sines and cosines, and let's see what happens. A secant is 1 over a cosine. Cosine is okay, and the sine is okay. And I've run out of room, so I'm going to rewrite it over here. Your goal, your ultimate goal, is to make this look simpler. Obviously, you have to make it uglier before it becomes nicer. Would you agree there's a big problem with this guy here?
Doesn't it just equal 1 or negative 1? 1 divided by cosine minus cosine.
Oh no, yeah, I see what you're getting at. No, they don't interact that way. That's a bit like saying 1/2 take away 2, right? They're not the same thing. You can't combine them, but I think I know what you're getting at. I'm going to do a bit of algebra, and I'm going to use, because I use this trick a lot. I don't like this 1 over cosine. There's no point in me turning it back into that because that's where I started, right? So I want to keep the cosines and sines, but I just don't want that fraction. Right? I want it to go away. And so I'm going to multiply by a special version of 1. And the special version of 1 is cosine over cosine. You comfortable with that? Let's see what you get. Cosine times this guy gets me cosine. Cosine times this guy gets me negative cos squared theta. And on the bottom, I get a sine theta, cosine theta. And I said something that's wrong there. Shouldn't that be 1? There. I'll rewrite that again. That times cosine just gets you 1. So we are now looking you're always trying to slowly but surely peel the onion till you get to the center, right? Till it's as simple as it can be, right? I've now got rid of that ugly fraction, and I'm now looking at this fraction. And I'm always on the lookout for things that could be turned into other things. Do you see this top 1 minus cos squared? What does 1 minus cos squared?
Equals sine squared.
And every time you do it from now on, shouldn't your goal be to try and make it simpler? Right? Would you agree sine squared's better than 1 minus cos squared? And if things work out like they do here, won't you get something that might cancel or simplify in some nice way?
Isn't it just sine over cosine, which is
Okay,
equal
so
to
I'll divide the top and bottom by sine, and I'll write down what you just said. Isn't it just sine over cosine? You are correct. But what's sine over cosine?
then it goes
Tangent?
to tangent.
Tangent. Do you see how convoluted that question was? Turned it into sines and cosines. Oh God, look at that top. I don't like that top. Okay, let's get rid of the weird fraction. Do the special version of one trick. Ah, I got a 1 minus cos squared. Hey, I remember him. Right? Sine squared. Oh, cancel. Oh, you see, it kind of works. It's kind of like unfolds as it goes. If you're going the right way, things tend to, become nicer and nicer until you get to a place where, well, you can't get much nicer than that. A grade tan theta is pretty good. But every question is kind of different in its own way. Here is a version of question 6.
Can I ask why
Oh, yes.
we are learning this?
Oh,
What's the purpose of it, I guess?
I'll tell you right now. Some of you, maybe not all of you, but for those who do, are going to go into calculus. And I, right now, I'm teaching Calc 1, 3, and 4. And every single one of those students, at least 2 or 3 times a week, has to take a trig expression and rewrite it some other way to allow you to differentiate or to integrate or to find the moments or whatever we're doing. It's a bit like you're learning how to factor because later on, factoring things is going to help you answer puzzles. So right now, you are just doing a pure skill building exercise, how to make trig things look pretty so that later on you can do things with those trig things. The pretty version, not the ugly one that you started with. I don't know if that helps you, but that's the reason.
It
Right?
did, thank you.
Okay, so we got 2 sine x, secant x, okay, over tan x. Let's just chuck you in at the deep end. It's a great way to learn to swim or drown. So whoop, you're in. 2 minutes, make that guy look pretty. Two minutes, no pressure. Oh God, no, you're not getting 2 minutes. You're getting 1 minute. I just saw the answer. If you do it right, there should be at least 2 of you who get it correct.
I think I got it.
If you have got it, does your answer kind of look like a squiggle?
Yeah.
Okay. Right, let's go for it. Turn everybody into a sine or a cosine. A secant is 1 over a cosine. And a tangent is a sine over a cosine, although you didn't actually need to do that. So what do I have? 2 sine x over cosine x all over a sine x over a cosine x. Do you notice that they cancel and the answer's 2? Or you might have recognized that the top was 2 tan x.
I got sine times cosine.
Oh, it's sine times 1 over cosine. That's where you went wrong then. Because a secant is a 1 over cosine. So if you're doing 2 sine x times 1 over cosine x, think of it like that. The top 2 together and the bottom 2 together. You see the cosine is in the bottom, not next to the sine. That was, I'm surprised. I didn't realize that until after I'd given it. Cos cubed x plus sine squared x times cosine x. We're going to simplify it. Well, I don't need to turn them into sines and cosines because they already are sines and cosines, agreed? So this is a new puzzle. What do you think you might want to do next? Is there anything on this expression and this expression that might play well together?
Could you combine the cosines?
Sine to the 4th.
Well, let's not so much, these are being added, but certainly we'll use the cosines. The way I would phrase it, although it might mean what you were saying, is I'd pull out the cosine x as a common factor. And if you pull out the cosine x as a common factor, do you see what you get? Pull it out of here, you get cos squared. Pull it out of here, you're left with a sine squared. Wait a minute, do you know that guy? What's he equal to?
1.
Doesn't matter if it's sine squared plus cos squared or cos squared plus sine squared, doesn't it the same thing, so it was 1. And cosine x times 1, there's a very, very nice answer. It's equal to cosine. You like that one? But isn't it different from all the others? Have you noticed that almost all of them are different from the other ones? That's the trick. That's the problem. You got to be able to have a kind of open mind and think to yourself, turn everything into sines and cosines, factor things out, add fractions together, multiply by special versions of 1, right? All those kind of things, you know, whatever it takes to make it happen. I don't like question 8, but I'm going to have to show you. It is ugly. I could give this one to any of my calc students, and I'd be amazed if more than about half of them could do it right. So you're going to be looking at a horrible, horrible question that ends up being a very nice answer. Right. So I'll just try and take you through my thought process. As I look at this, I'm saying, oh, well, everybody's a sine and cosine, so I ain't got that, right? Can I factor anything? Nah. Is there anything in there that's already an identity that I could switch it? Not really. So I'm not going to do any of those things because I can't, right? There's no advantage. So I'm left with 2 ugly fractions. And since it's a good idea to have one ugly thing rather than two separate ugly things, I'm thinking I need to add these. I need to get them together. And adding fractions is something you don't get a lot of practice at. But hopefully you remember one of the things about adding fractions is that don't they have to have a common denominator, right? The bottoms have to be the same thing if you're going to add them. This fraction has a cosine u on the bottom. This fraction has a totally different 1 plus sine u. So I'm going to change this fraction the way it looks and this fraction the way it looks so that both fractions have the same common denominator. And I'm going to do it by that multiply by a special version of 1 trick. So I'm going to multiply this fraction by that version of 1. What do you think I'm going to multiply this fraction by then? What special version of 1 will I do on the second fraction?
Cosine over cosine.
Can you see how that's going to help in getting the two fractions together, right? So what I have now is a shared common denominator of cosine u 1 plus sine of u. Unfortunately, I don't have much on the top that looks nice. I have a sine u and a 1 plus another sine u. And then I've got, well, I can multiply them together. I have a cos squared u. Doesn't look too promising yet, does it? Are we good? Right, what do you think I should do next? I know this is the first time you've seen it, but what's your gut feeling for what might be a good idea next?
Can you not cancel that?
Oh, like this cosine here with that one, that kind of
Yeah.
thing? You're only allowed to cancel when it's totally factored. So when a factor on the top is allowed to cancel a factor on the bottom. But if you get something plus something else, you're not allowed to do that, unfortunately.
Okay.
But it would have been nice if we could. So I like the way your brain's thinking. And we are going to cancel, but not yet.
Wouldn't you multiply the 1 plus sine times 1 plus sine?
Right, and can you just trust me that when you FOIL it out, you get that. And the cos squared u is still there. Okay, that's where we are right now. Every time you do something, you pause and you look at it fresh and you think, I wonder if there's anything I can do to make it nicer. I can see something we can do to make it nicer. Can you see what I can
sine
see?
squared plus cosine squared is equal to 1.
And every little bit helps. Would you agree we can add the two ones together and get 2? And I probably should have done that, but I'm trying to write every line I can think of. Essentially collecting like terms. Keep trying. Is there anything else I can do to the top that might help us get somewhere? 2 plus 2 sine u. Anything you can think of.
Could you factor out the 2?
Yeah, doesn't seem like it's much good until you do it. Oh, would you look at what just happened? Now, I think it was Aaron, you were talking about cancelling. Can you see that because the top's now factored and the bottom's now factored, can't we do some
Yeah.
cancelling?
Yeah.
And who
that
can we
has to be
cancel?
multiplication.
So who will we cancel?
The 1 sine u.
And now we are left with 2 over the cosine of u. And remember the rule about trying to write it so it's not a fraction if we can. So what does 2 cosine u get rewritten as?
Is
2
that
over.
2 secant?
That's the secant one. Look at the original and look at how nice the answer is. Isn't that kind of amazing, that ugly thing? Now, can you imagine you were doing something algebraic in, say, whatever that is, calculus, and you were starting with that? Wouldn't it be much nicer if you could work with this guy? Right? I mean, just whatever it is you're going to do, right? Differentiate it, whatever it happens to be. Wouldn't this be the guy that would make a lot more sense to work with? But no arguments. Is that not a stinker of a question, right? That is something you really would fight hard on if you haven't done it. Oh, we've tons of time. This one is probably just as ugly as the one we just did. Maybe a little bit less ugly. I don't know. That's a matter of taste. And that funny little symbol at the side is called alpha. So a over 1 minus sine alpha plus a over 1 plus sine alpha. Now, what makes this similar to question 8 is, isn't it 2 fractions? And I want to make 1 fraction. And that means I'm going to have to do special version of 1 trick again, right? I want these two to share a common denominator. What version of 1 will I use on this fraction? Top and bottom, what version of 1 will I use on this one? And then what version of 1 will I use on this one? So they share a common denominator, and then I can add them. Any suggestions?
Would you do 1 plus sine
You did.
alpha?
Why was that's the right thing to do? What was going on in your brain?
Well, in order to get them both to have the same denominator, you basically have to multiply by each other's denominator of 1.
Right. So that's the trick. If you have 2 fractions that you want to combine, multiply this one by the special version of 1, whatever he is, and multiply this one by the special version of 1. And just like you said, you see they now both share the same 2 terms. Right. So that's, if you're wondering, where did these special versions of 1 come? How did I pull them out of the hat? I didn't really. I looked at that and said, you need this guy. I looked at that and said, you need this guy. That's kind of what we did. Now, the top gives you that guy plus 8 times that guy. And the bottom looks like that guy. Okay. Got them together. That's always good. Right. What do you think we should do next? Well, sometimes it has to get uglier before it gets nicer. What should we do next?
You could combine the top 2.
Okay, so that could be true. I'm not quite sure how you'd want to do it. How are you going to do the combining thing? I would definitely combine them, but how would you do it?
By factoring in, I guess, the 8. And then
Oh,
use
that's
5.
not the way I thought about it, but that actually works, so I'm going to do it. Can you imagine I pulled out a common factor of 8? I was thinking of distributing, but yours is just as good, so I'll use that. Do you notice anything interesting that's going inside here? Is that plus sign and that negative sign? Don't they cancel out? So what you're left with is 8 times 2 over this guy. So combining the top, good strategy. I guess I should have probably skipped that line. That's about 3/4 finished. It looks like it's finished. It looks like there's nothing left that you could do. But there is some more that we could do. I think we fixed the top, right? You can't get much better than a number, right? So I'm not going to work about that. What do you think I should do with the 1 minus sine alpha times the 1 plus sine alpha?
Turn it to cosine squared and sine squared.
I'm not sure if that's right. It might be, but the way you phrased it just didn't sound right to me. Are you talking about multiplying these out and then getting things with sine squareds in them?
Oh no, it's okay. I
Okay,
said
so
something.
you were thinking of something else. I got you. Yeah, you're thinking. I like thinking. You know, half the time I think the wrong thing and then I learn from it, and the next time I do it a bit better. So, what do you think I should do with these two things here? I mean, what's left to do with them? I guess.
Should you just distribute?
Yeah. And if you distribute, if you multiply using FOIL, you're going to end up with 1 minus sine squared alpha. You might think, what happens to the plus and minus? They cancel each other out. So the plus sign and the minus sign disappear. Now that guy isn't much of an improvement, but it is better. Does anybody recognize 1 minus sine squared somebody? Because I can see something up here that I could change that into. 1 minus sine squared.
Cosine squared.
Okay. I know it might not seem a little bit improvement. Would you agree that's pretty big? That's a little bit nicer. Would you agree that's even nicer? And then to finish, shouldn't we try and write it so it's not a fraction? Now, if it was 16 over cosine, wouldn't it be 16 secant? So 16 over cos squared just gets you 16 secant squared. Finished. Are we cool? Yeah. The next bunch of questions are a bit weird. I guess weird's the only word I can think of right now. Because they don't look like there's a question. You're being asked to verify. I would prefer the word prove, but that's fine. Verify that sine x plus cosine x squared is equal to 1 plus 2 sine x cosine x. A good way for me to look at this question is, that is the question. This is the answer. Our job is to prove that this is equal to that. So it's a bit like somebody giving you an equation and telling you the solution, and then you're just going to solve the equation and get the same solution. So I'm going to simplify this expression, or at least rewrite it, so that it looks like this one. And this, when we do it, is verify the identity. That's what we would phrase that as. Okay, so let's just focus on the left-hand side. And when we're finished, shouldn't it look like the right-hand side and we're done? Okay, what would be a good start to sine x plus cosine x all squared? What would be a good starting point?
Get rid of the squared, maybe.
Okay, so to get rid of the square, I have to realize that I need to FOIL it.
Yeah, and then just distribute it. Sure.
Okay, and if you do the foiling, it takes me longer to write it than it does to do it, you end up with this guy. Now the two terms in the middle get me 2 sine x cosine x. And what do these two guys get me? What is a sine squared plus a cos
1.
squared? Gets me a 1. Have we got the answer they told me it should have been? Right? Bit weird that, isn't it? That you don't normally get questions where they tell you what the answer is, right? Normally you get the question and your job is to find the answer. But what we're doing here is verifying the answer, right? We're basically saying, I can prove that what you said is the answer. I can get the same answer, right? I can prove it. Are we cool with that weirdness now that we know what they're on about?
Yeah.
Right. So let's move on to the next weird one. In question 12, we are being asked to verify that cos x over secant x plus sine x over cosecant x is equal to 1. And you get a big box where you have to type in all your workings. So here goes. Right. Oh, I better move this out of the way.
You're
so we
not
can see it.
sharing.
I'm not? Oh. What? There we are. Am I sharing now?
Yep.
Yeah.
Okay, here we are. We're back to where we were last time. Right, so we're being asked in question 12 to prove that this guy plus this guy is 1, right? So forget about that. Let's focus on him. What would be pretty much the first thing I should do in this question?
Well, you want to get all cosines and sines.
Okay, so we are going to be stuck with some really weird, ugly stuff. So it's going to be 1 over cos x, right? And then it's going to be sine x over 1 over sine x. Are you with me so far? Now, that is a weird, weird looking fraction, isn't it? And this is an equally weird looking fraction. I'm not going to add these fractions together yet. In fact, all I want to do is to try and make them a little bit prettier, right? And then see what we get. There are 2 different approaches, both work. How about this one? Top guy divided by the bottom guy. Agreed? A fraction could be thought of as the top thing being divided by the bottom. Wait a minute, isn't that the same as multiplying by the reciprocal? Remember that trick? And so what do you get? You get cos squared x over 1, which is just cos squared x. Now, if you go over here, you're going to have top guy divided by the bottom guy. The sine x multiplied by the reciprocal. That's going to get you sine squared x over 1. And do you recognize cos squared plus sine squared? In a way, isn't it kind of helpful to know what your answer should be? Right? Because it kind of gives you an idea, I finished. Because you imagine some of the ones we did before, you could look at it and think, yeah, that's as good as it can get. Wouldn't it be nice if they said, oh, by the way, this is what it eventually is equal to? Wouldn't that be a clue? Okay, there's more to do. And this, you know there's more to do, right? If I got to there and I thought, well, that's the answer. Do you see that it's not? You know there's more to happen. We have a cos squared, subtract a sine squared. And that's going to be, or we're going to prove that it's the same as that guy. Now, everything's sines and cosines. Nothing much I can do here. But I know what the answer needs to look like, and I know what I'm starting with. And I'm going to look at this, and I'm going to look at that, and I'm going to see, is there anybody over here that could help us? There's only coses here, right? Only cos squareds here, right? That's the clue to me. Is there anything over here that we could use with these guys?
Turn the sine into a cosine.
Okay then. And a sine into a cosine would be 1 take away cos squared. Great. And cos squared x, take away 1, take away a takeaway is add. Hey, nailed it. Right, finished. One take away cos squared x, 1 plus cotangent squared x equals 1. Right. Everyone's unique in its own way. This is going to be our last one for today. Give me a starting point. Give me something to do.
Oh, multiply.
Turn the cotangent to sine or cosine.
Okay, that's a good start. So cot squared becomes sine squared x over cos squared x. Okay? What do you want to do now? That's a good start. I would definitely do that. What would you do next?
Foil.
Foil. Okay. 1 times 1 is 1. 1 times this is an ugly looking thing called sine squared x over cos squared x. That guy times that guy is negative cos squared x. And this guy times this guy, check that, negative cos squared x. And this guy times this guy is negative sine squared x. Okay. I like it. It's not obvious, but these two guys are a number. What number is negative sine squared, negative cos squared?
Wouldn't it be
1,
1 or negative 1?
-1.
Negative.
So what I'm now looking at which is now going to be, that's weird. That's not right. Did I write it down wrong? No? Okay, that's good. I know it's not going to be what I want, so I'm trying to figure out what I did wrong. Let's check this. 1 plus sine squared over cos squared. Okay, I can handle that. Minus cos squared, I can handle that. Minus sine squared, I can handle that. That's -1. That's that.
Well, I was thinking about doing, which I thought might make it easier, is you can 1 minus into sine.
Oh, right. If you use 1 minus cos squared x, it's sine squared x. So this becomes sine squared x, 1 plus cos squared x over sine squared x. And then I could multiply it through. That's sine squared x. Oh, plus cos squared x. And the answer is 1. Okay, so it definitely is 1. What did I do wrong here? Because it should be 1 in this method as well. Oh, there it is. Didn't I call the cotangent sine over cosine? What is the cotangent? It's not sine over cosine, is it?
Cosine over sine.
Right, I bet if you do cosine over sine, the whole thing works. So that's where my mistake is. This should have been cos squared over sine squared. And then if you did all the multiplication, you get, yeah, it would come out pretty. And you'd get 1. And that's a good time to finish. Say your last name. And I will see you tomorrow. I will hang about for any questions and homework